Hi everyone, this is Shivprasad and along with me is Tejas. So for the paper presentation, we are presenting the paper Can Icons Outperform Text? So these are basically using pictograms, HOM and OHMDs. So for what, why and how? So this research basically is focusing on optical see-through head-mounted displays such as smart glasses. Examples are Apple Vision Pro, Google Glass, Microsoft HoloLens. So why is this research taking place? Is that in multitasking scenarios, when you are interacting with the real world as well as the virtual interfaces, at that time, your efficiency or your work performance should not reduce, or you should not have any interruptions. These notifications should be concise and intuitive. And as I already said, that OHMD notifications interrupt the user's primary task. How should we design the notifications then? So pictograms, icons, and signs are commonly used for our navigation and interacting with our computing devices. Also, in communications, emojis are used nowadays, and also they are used in emergency scenarios. And also that people with intellectual disabilities can easily understand through these emojis or signs. So using this, these icons augmented notifications have been designed. So what improvement does it bring in HCI? So these notifications are used in multitasking scenarios. It also brain imaging shows that icons are not processed as logographical words, and icons itself can be difficult to interpret. If I just show an icon, it is difficult to understand what it means. So what is the alternate approach? So in this research, as you can see in the examples, there are regular text notifications showing that doctor's appointment in 2 hours. So the primary and secondary information is doctor's appointment, and secondary information is 2 hours. And the icon augmented notification clearly shows that the stethoscope signifies the doctor's appointment, and the 2 hours is the secondary information. So using this in multitasking scenarios, OHMD notifications can be designed. So the icons for our information, icons used are from Google Material Icons and Vatican website. So the summary of the paper is that it is for optical see-through head-mounted displays. For presenting digital information, we can use text or pictograms. In this research, there are 4 studies that have been made, and these notifications can outperform text depending on the icon familiarity, the encoding density. In the previous example, doctor's appointment and the stethoscope signifies that the encoding density is 2, and the environmental brightness so that it doesn't interfere with the notification. So in the research, the apparatus shows that the smart glasses used here are Epson BT300, and there are 4 studies, and there are 2 types of studies that have been made. One is the control setting and one is realistic setting. So in the right, the apparatus shows that it's control setting. So coming to the metrics, so the measures are based on the IRC framework. The parameters is interruption. So if the user is actually getting interrupted in their primary task, the reaction, how quickly the user notices the notification, the comprehension, that how quickly the user can understand the notification, and the satisfaction, if the user is satisfied with the notification or there could be a better notification. Now, as I said previously, that I will talk about the control setting. So this performance metrics in the software on the right side, as you can see the examples, the notification has been displayed. One is the text and one is the pictogram format. So the notification has been displayed and there's a white box. So when the white box appears, the user has to click on the box. Next example, you can see that there's also a rectangular box. If the user clicks that, that is a false alarm. So now mapping that to the performance metrics, if it's a white square that is being clicked, it's a hit. If it's a rectangular box, then that's a false alarm. The reaction time is how quickly the user can click on the box while the notification is being displayed. Then there's a RTLX, which is raw NASATLX score, which is a metric that actually analyzes your brain to check if there's any physical demand, mental demand, frustration, or interruption in your task. And lastly is the perceived interruption. So if there's any interruption caused while you're multitasking while using this notifications. So from here, Tejas will take over. Thank you.
There were 4 studies in total that were done in the research paper. out of which three were in the control setting and one was in the realistic setting. Study 1 compared the icon augmented notifications and the text notifications. Study 2 compared icon augmented notifications with their transformed text notifications. Transformed text means that the icons were literally converted into their text meanings, that is, without any filler words. Study 3 did the same as of study 2. In the icon augmented notifications, the notification icons were selected by the users, not the researchers. But in study 2, it was the opposite thing. Now, coming on to study 1, compared the icon augmented notifications with the text notifications. In total, there were 24 calendar notifications that were used in the icon and the text formats. Out of which, six notifications were displayed for the two scenarios. It was observed that lower task load was on the system than the text notifications. Physical demand was an exception in the raw NASA TLSX score, as it didn't show a much of an increase or decrease in the values in the scores. As we can see here, that mental demand, temporal demand, performance demand, effort, and frustrations had some kind of minimum standard deviation in them. No notifications, then icon augmented notifications and text notifications were preferred in the particular order. In the study 2, the results were contrary to the study 1. Lower hit rate and similar reaction time was found than in the text formats. In here, 12 calendar notifications were used with the augmented and transformed text format. The researchers noticed a comparable data due to the removal of filler words as to now coming on to study 3. The study 3 compared icon augmented notifications with the transformed text notifications, where the icon augmented notifications had icons that were selected by the user. This had the same lower task loads and mean values than the text format, but the mental demand, performance demand, and effort had significant main effects on it. As seen, here also physical demand is an exception. Study 4 was done in order to verify whether the lab setting results can be generalized to the realistic world environment. So in here also, icon augmented notifications were compared with the transformed text notifications in the realistic environment. By realistic environment, it means in here the users were wearing OHMD and were asked to follow a route while doing the day-to-day things. In here, alternative icon augmented notifications and text notifications were used at a minimum of 40 seconds of gap in between. Time of the experiment was randomly assigned to increase generalizability. Removable lens shades during the navigation was to ensure the visibility of the notifications in the outdoor environments. The outcome of the study shows that during navigation tasks, longer text formats were more distorting than the icon augmented ones. During the browsing tasks, both formats were similar in the distraction levels. There was no significant difference in the formats of immediate recall accuracy, and the text formats showed a higher understandability ranking during the browsing task. We can see here from the measures that are shown on the screen, the mean for icon augmented notifications with encoding density of 2 had higher level of recall accuracy, noticeability, understandability, and higher RTL scores. Now about the usability testing and its score. The authors chose a lab-based and a realistic setup for the usability testing. This setup is commonly used for both industry and academy to gather quantitative data, and it involves testing a new website or an application with participants in the controlled environment while observing and collecting data. It is more of a qualitative study rather than a quantitative study. The control setup ensures minimum distractions and allows it to strictly control over environmental conditions such as the noise, and it can unintentionally affect. Controlled experiments are more widely used in HCI research than in industry. Why did the authors choose this particular methodology? The vigilant task was chosen for two key reasons. Firstly, it effectively replicates real world scenarios of optical head mounted displays, especially in dynamic and unpredictable environments. This is crucial when attention must be split between OHMD's visual content, that is notification, and the physical environment, that is the shape detection, such as when walking in crowded areas. It enables the measurement of how well the user maintains visual attention, and perceptual monitoring when exposed to virtual environment, impacting gaze, attention, situational awareness. Not all participants were familiar with the researcher selected icons. Less familiar icons were found to be confusing and harder to recall, particularly if they weren't relevant to their personal lives. Now talking about what more can be done in this case. The lack of metrics and tools for calculating the effectiveness of environmental brightness wasn't available as this could have been added more to the research. And a quantitative study would have proven more points than the qualitative study that the users have done, as there were only 12 users that were taken into consideration at the time of the research. That's it for the presentation. Thank you.